Hello everyone. On this video we will figure out how to solve absolute value equations. Okay, so to do that, the first thing we're going to do is give you kind of an understanding as to where the formulas we're going to use will come from. Okay, so just remember your absolute values. So let's say absolute value of negative 12, we know that is equal to 12. And let's say the absolute value of positive 18, we know that's equal to 18. So whether it's negative inside of here, it's going to equal a positive number. And whether it's positive inside the absolute value, it's going to equal a positive number. Okay. Now the general idea of an absolute value, the absolute value measures the distance from the origin. Alright, so let's say we have our number line. Okay, so we'll say this is 0, which of course is our origin. Okay, this is 1, 2, 3, 4, 5, 6, and it keeps on going all the way to positive infinity. Okay, so let's say we go the other direction. We have our negative 1, negative 2, negative 3, negative 4, negative 5, and it keeps on going all the way to negative infinity. Okay, now once we do that, let's say if we pick a value, let's say the absolute value of negative 4. Okay. Now the absolute value of negative 4 is equal to 4 because the distance from 0 to negative 4 is 4 units. It could be 4 feet, 4 inches, depending on what unit of measure you're using. Okay? Now let's say if we have absolute value of positive 4. How do we know that equals 4? Because the distance from 0 to positive 4 is also 4. Okay, so this lets us know that absolute value of negative 4 equals 4, and absolute value of positive 4 equals 4. So this lets us know that it could be either a negative 4 inside the absolute value bracket or absolute value bars, or it could be a positive 4 inside the absolute value bars, and we'll still get the same answer. Okay, so that general idea will give us our formula. Let's say absolute value of x equals k means that x can equal k or x can equal negative k. Okay, so that means this value inside the absolute value bars can be either positive 4 or negative 4, and it'll give us the same 4 value. And we're just applying it to a general formula. So this is the general idea. For the absolute value of equations. Formula. Alright, so hopefully that made sense. So now we're going to apply it to a few examples. Alright, so let's say, for example, if we wanted to solve the absolute value of 2 over 3x plus 3, then plus 4 equals 10. Alright, so the first thing you want to do before you can solve an absolute value equation is to isolate your absolute value. Okay, so first you want to do, isolate your absolute value before trying to solve. Okay, so that means if we have our absolute value of 2 over 3x plus 3 plus 4 equals 10, we're going to subtract 4 from both sides, which gives us the absolute value of 2 over 3x plus 3 equals 6. Now this is what we're going to solve. Let me kind of expand that a little bit. Okay, now remember, this is an equation. So if you remember that absolute value of x equals k means that x equals k, or x can equal negative k. Okay. Now how we apply that to this is the exact same thing. Absolute value of 2 over 3x plus 3 equals 6 means 2 over 3x plus 3 equals 6, or 2 over 3x plus 3 equals negative 6. Okay, so that means this absolute value can equal one or the other. Okay, so I can focus that a little bit better. That's a little bit better. Okay, so all we have to do now is solve both of those, and we'll have our answers, or possible answers. Okay, so let me just separate that. So we have 2 over 3x plus 3 equals 6, and 2 over 3x plus 3 equals negative 6. Okay, so if we go ahead and subtract 3 from both sides here, and we have 2 over 3x equals 3. Okay, so if we go ahead and multiply both sides by 3, where those two will cancel out, we have 2x equals 9. So if we divide both sides by 2, we end up with x equals 9 over 2. Okay, same thing here. We go ahead and subtract 3 from both sides, and we end up with 2 over 3x equals negative 9. So if we multiply both sides by 3, where those two will cancel out, we will have 2x equals negative 27. So once we divide both sides by 2, we have x equals negative 27 over 2. And erase that there. Now, with those answers, we could always check them. Just make sure they're true. You don't have to check them, but I do recommend checking them at least until you're comfortable and you've had enough practice with this. Once you've had enough practice and you're comfortable with it, then you can kind of bypass the check. Okay, so we're going to go ahead and check this answer. Now, remember, we're using this formula. So all we're going to do, move that up a little bit, is replace x with 9 over 2. So we have the absolute value of 2 over 3 times 9 over 2 plus 3 equals 6. Okay, so these 2's cancel out. 3 goes into 3 once. 3 goes into 9 3 times. So we have the absolute value of 3 plus 3 equals 6, which gives us the absolute value of 6 equals 6, which is true. So we know this answer is good. Okay, we do the same thing here. We just check our answer. So we have the absolute value of 2 over 3, and instead of x, we put in negative 27 over 2 plus 3 equals 6. Okay, so those 2's cancel out. This 3 cancels out, and this becomes a 9. So we have the absolute value. Remember that negative is still there, so you have negative 9 plus 3 equals 6. Negative 9 plus 3 is 6, so the absolute value of negative 6 equals 6, which is true. So that answer is good. Okay. Remember, you don't have to check it, but it is highly recommended. Alright, so let's go ahead to our next example. Straighten up my papers here. Alright, so let's say, for example, you want to solve, say, 3 times 1/2 x minus 5 minus 4 equals negative 4. Alright, so remember, the first thing you want to do is isolate your absolute value. Isolate your absolute value. So that means our 3 times 1/2 x minus 5 minus 4 equals negative 4. We're going to add 4 to both sides. Okay, so that gives us 3 times the absolute value of 1/2 x minus 5 equals negative 4 plus 4 is 0. Okay, so by isolating the absolute value, that means getting rid of that coefficient 3 also. It has to be nothing but the absolute value term. No coefficients. So we have to divide both sides by 3. Where these two 3's cancel each other out. And we are left with the absolute value of 1/2 x minus 5 equals 0 divided by any number other than 0 is equal to 0. Okay, so now this is the absolute value that we're going to solve. Alright, so to solve that one, again, you want to remember absolute value of x equals k means that x can equal k or x can equal negative k. Okay, so applying that to this problem, it means that the absolute value of 1/2 x minus 5 equals 0 means that 1/2 x minus 5 can equal 0 or 1/2 x minus 5 can equal negative 0. Okay. Now in this case, 0 and negative 0, the exact same thing. Negative 0 is just 0, so we don't have to solve it twice. We can just solve this one and we'll be okay. Okay, so if we have our 1/2 x minus 5 equals 0, we add 5 to both sides, we have 1/2 x equals 5, and meant to draw my arrow a little further away, so that if we multiply both sides by 2, Those two will cancel out, and we end up with x equals 10. Okay, now you don't have to check it, but if you wanted to check it, your absolute value of 1/2 x minus 5 equals 0. We're just going to replace that with x equals 10. So absolute value of 1/2 times 10 minus 5 equals 0. 1/2 times 10, or 10 divided by 2, is 5. So that's absolute value of 5 minus 5 equals 0. 5 minus 5 is 0. So absolute value of 0 equals 0, which is true. So we know that that answer is good. All right. So now we're going to go ahead to our next example. Okay, so let's say, for example, we want to solve the absolute value of x plus 4 equals 20. All right, and I want you to go ahead and press pause and solve this one on your own. Alright, so assuming you have pressed pause and you have already solved this one, we're going to go ahead and verify your answer. Okay, now for your first step, you don't have to isolate the absolute value because it's already by itself on the left-hand side. So it's already isolated. Okay, so you can skip that first step. Okay, so that means you have the absolute value of x equals k, means that x can equal k, or x can equal negative k. So applying it to this problem will give us the absolute value of x plus 4 equals 20, means x plus 4 can equal 20, or x plus 4 can equal negative 20. So now we just solve both of those. Okay, so if we go ahead and solve those two, so we have x plus 4 equals 20, and x plus 4 equals negative 20. We subtract 4 from both sides here. That gives us x equals 16. And if we subtract 4 from both sides here, that gives us x equals negative 24. Okay, so once again, you don't have to check, but we're going to go ahead and do a quick check. Okay, so for x equals 16, we're just going to plug it into our original equation, this one or this one, same thing. So absolute value of 16 plus 4 instead of x plus 4. 16 plus 4 equals 20. So that shows absolute value of 16 plus 4 as 20 equals 20, which is true. Okay, so we know this one's good. What about this one here? If we check this answer, we have the absolute value, instead of 16, we have absolute value of negative 24 plus 4. So negative 24 plus 4 equals 20. Negative 24 plus 4 is negative 20. So we have the absolute value of negative 20 equals 20, which is also true. So both of those are true answers. Well, true solutions. All right. So let's go over one more example for our absolute value equations. But before we do that, I'm going to give a quick explanation on how we're going to solve it. Okay. So if you remember, for example, absolute value of negative 3 is equal to 3. And we know that the absolute value of positive 3 is equal to 3. Okay, now this answer is equal to 3, and this answer is equal to 3. then that means that the absolute value of 3 is equal to the absolute value of negative 3. Because that answer for both of those would be 3. So this right here will also give us an additional method. So in general, if you have the absolute value of x equals the absolute value of y, that means x can equal y, or x can equal negative y, which is pretty similar to what we have already, but the x and y kind of represents expressions. Okay, so I'll show you what I mean by that and how this is useful. Okay, so let's go to our example on this one. So let's say if we wanted to solve absolute value of 5x plus 3 equals the absolute value of 3x plus 5. Okay, so it's a little bit different. Okay, so when both sides are absolute values, you remember that the absolute value of x equals the absolute value of y means that x can equal y, or x can equal negative y. Okay, so we're just going to say that this absolute value term is your x, and these absolute value terms represent your y. Okay, so if we apply that to this problem, you have the absolute value of 5x plus 3 equals the absolute value of 3x plus 5, means that 5x plus 3 equals 3x plus 5, or 5x plus 3 equals negative 3x plus 5. Okay, so it's very important to put the parentheses around the term on every term on your right. You want the entire right. It's the negative of the whole thing. If you just put the negative in front of the 3, you'd get an incorrect answer, because it'd be negative 3x plus 5, and that wouldn't be correct. You want the negative of that entire right side. Okay, now just like before, we just go ahead and solve both of those. Okay, so we're going to just put that up there. So we have 5x plus 3 equals 3x plus 5. And we have 5x plus 3 equals negative 3x plus 5. Okay, so if we go ahead and subtract 3x from both sides here, 5x minus 3x is 2x. So we have 2x plus 3 equals 5. So if we go ahead and we subtract 3 from both sides, those two cancel out. So we have 2x equals 2. So once we divide both sides by 2, we have x equals 1. Okay, so again we solve here, but first we just distribute the negative. Okay, so 5x plus 3 equals negative 3x minus 5. Okay, so this time we're going to add 3x to both sides. 5x plus 3x is 8x. So we have 8x plus 3 equals negative 5. So we subtract 3 from both sides. That gives us 8x equals negative 5, and negative 3 is negative 8. So if we divide both sides by 8, we have x equals negative 1. Okay, so if you wanted to, you can go ahead and plug those in and check them. But those are your two solutions. Okay, so hopefully this made sense, and I will see you on the next video.